Chapter 9 is called Analysis of Variance. We use this to make pairwise comparisons of more than two means. We'll cover 3 different types of designs in the chapter. So I'm going to break the PowerPoints into 3 different lectures. We'll cover the examples, take a quiz, and then go to the next type of design. This will be our last chapter for the whole semester. Observational data has not been extracted through any prescribed methodology. We may get the data ourselves through convenience samples or from secondary sources. So forms of observational data could come to us through warranty cards that customers fill out or when they register their products online. Or we might actually observe what customers are buying off the store shelves. Data from these observational studies could be divided into either retrospective or prospective time elements. So retro is what it sounds like, historical data, and prospective would be data where you're currently gathering. So as events unfold or if we have online real-time data. Much of the data we get in business is observational, but those instances where we can create an experiment, we would prefer to do so. We would have a particular type of model in mind when we start gathering the data. We would randomly assign the subjects to the groups, and we would have some element of control within those groups. All of this will help us try to reduce any form of bias that would be in the experiment. So the example I've given you is that if you're investing in a new business, your prospectus may include a study to see if the mean number of people passing by daily differ based on location. So what if you had a new business you wanted to put in and your choices were to buy a location either downtown, on Baylor campus, or out near the new mall at the Central Texas Marketplace. If the study randomly took samples from the 3 different possible sites and controlled the hours the samples were taken to represent regular business operating hours, it would be an experimental design. Elements of a design include the experiment, factors, levels, treatments, and response variables. The experiment is defined as recording or measuring some outcome. The factors are the broad categories that are being manipulated. So in that example, it would be location. Then the levels are the specific locations. So that would be Baylor, downtown, Central Texas Marketplace. Our treatments would be all combinations of the factors and levels. And then finally, the response variable is the variable that's being measured. So the average amount of traffic by each location daily. The principles of design can be categorized into 4 areas: control, randomization, replication, and blocking. So what is control? We may control the environment of the test subjects or use a control group such as those in clinical trials where that group receives a placebo and not the actual drug. Then randomly assigning the subjects to the different levels is one way we can keep our bias from entering the study. The third principle of design is called replication. This could have one of 2 meanings. We could simply have replication within each of the groups. If the sample sizes are the same for each level of the factor, then it would be considered balanced. If not, it's unbalanced, but we prefer balanced. A second kind of replication means we completely redo the experiment. Could be at different times and places even. This would ensure the reliability of our findings. A fourth principle of design is blocking. That means we have a second factor that's some type of classification or categorization. It could be based on gender, ethnicity, or marital status. How does the analysis of variance design work? Volume, which is defined as information, is increased by selecting the factors, choosing the treatments, determining the sample size. Then our error, or noise, is reduced when we randomly assign the treatments to each subject. The first type of design we're going to study is called completely randomized. It's also known as a one-way ANOVA. In this case, we have just one factor, and we're going to look at a study done by Dr. Carol Dweck from Stanford University. They took first graders and randomly assigned them to 3 different classrooms. In the first classroom, they were given a spelling test and handed it back after it was graded and praised the first room with, "Oh, you're so smart, you did great." The second room was praised with the words, "Oh, you did really well, you must have worked really hard." The third group is our control group, where they simply got their test handed back without any praise. We're going to look at the outcomes of this experiment. Here's how ANOVA works. It's going to control for the variation within the groups. So you see within the SMART group, not all the grades are the same, nor in the worked or the no praise groups. So it controls that variation. Then it says, is there a real difference in the mean amount of variation between the SMART group and worked hard, SMART and no praise, and worked and no praise? Hence, it's a pairwise comparison of more than 2 means. So when we define the elements of this design, the factor would be the type of praise, that general name for those different groups. The levels are the specific groups, SMART, worked hard, and no praise. The response variable is what we get the average on. In this case, their grade. And the control group again was the no praise group. Teachers controlled the word list for the 3 classes that were made up of random students. So here's the output. First, we test the overall model. Notice how we set up the hypothesis. Now we are using the symbol mu for means. So the mean of the SMART group equals the mean of the worked hard group equals the mean of the no praise group. HA is going to say at least 2 means differ. We look under analysis of variance and find the F statistic. It's 19.099 with a p-value less than 0.0001. Therefore, we're going to reject HO. And now we want to know which group is different. This is called post hoc analysis. You could look at the chart at the top called the Tukey-Kramer comparison, and where the 2 circles overlap, those are in the grouping for the no praise and SMART groups. But you notice the worked hard group has a circle all unto itself. It's the group that's different. And because it's up higher on the scale for the grades there, the worked hard group scored significantly higher than the other two groups, which were not significantly different from each other. Another way to tell which ones are different is to look at the connecting letters report. Notice the worked hard group is in Group A. They had a mean of 95. The no praise group has the letter B, and so does the SMART group. Their averages were 85 and 83.5, and they're not significantly different because they're in the same letter group. That's all we're going to do with completely randomized models. We'll go to the next type of design after we take a quiz on this.